All right, this is day 5 of our online class program. We are going to start the second half of Unit 3, and that starts with Lesson 3.5. Now, understand Lesson 3.1 to 3.4 leading up to that quiz was very algebraic, dealing with systems of equations, parallel lines, perpendicular lines, just mainly that idea of lines operating in the same space. The second part of this, starting with Lesson 3.5, we're going to get more to the geometric side of the unit. We will make connections back to Unit 2 because that dealt with segments. Now we're going to deal with angles. And the reason we deal with angles is because when we have these lines that are intersecting, what happens is they create angles. So here's an angle right there. So there's one angle, and you can see we can replicate that going all the way around 4 different times. Okay, so we have 4 angles in that intersection. Now, angles don't always get created in intersections, but we're just kind of building off what we did in lesson 3.2 and 3.3. So the part of the angle where the lines intersect is called the vertex. In this situation, C is our vertex. It used to be our solution, our point of intersection. Now, geometrically, it is our vertex. And if that angle was all by itself, then it would still be a vertex. The sides of the angle are called rays because they start at one spot and then they go on forever in the other direction, like a sun ray. Starts at its source and then it goes on forever. So it would start at C and then it would go through E. Or it would start at C and it would go through D. So since this is a very geometric section, we're going to look at how we would name a ray. So a ray is named using the vertex and another point. So the vertex being C, and it passes through E. And the marking above it is kind of a hybrid of a segment and a line. The arrow is always pointing to the right. We can switch the letters if the ray would be switched around. But right now I'm looking up here. It starts at C, so that's why we have this end point, and then it goes past E. Another one we have is ray CD. That cannot be ray DC or ray EC because the ray does not start at E or D, it starts at C. All right, now we won't name rays a lot, but we will name angles quite a bit. So an angle is named using the vertex and a point on each ray. So as I give the strategies for naming an angle, I'm going to use the example down below so we can see what that means. So a vertex and a point on each ray. So that would be the vertex and a point on each ray. So we're going to use the letter CTE. Now, since T is the vertex, it has to be in the middle. So this is going to be angle CTE. Or we can go the other way, ETC, as long as T remains in the middle. Another strategy for that would be using just the vertex. So in this situation, I could just call it angle T. Now that seems much easier, but if we would look up above, if I said angle C up here, you're not really sure which angle I'm talking about. But if I said angle ECD, then you would know which one I'm talking about. So there are benefits of the different strategies. And then the last strategy is just using a given number. So this would be angle 3. Numbers are not always available, but when they are, they tend to be the easiest strategy. And then it says we can name the two sides as our ray. Ray TC and ray TE. All right, if you need to pause right there and kind of take a look at that, naming angles will be important in this unit and next unit. All right, different types of angles. These are some things that you'll remember from earlier grades, maybe going back to middle school. So a right angle is an angle that measures 90 degrees. And it has that marking in it, so we know, in fact, it is 90 degrees. An acute angle is less than, let me write that out, less than 90 degrees. Obtuse is greater than. It's a bad arrow. Let me redraw that. And a straight angle is a line that measures 180 degrees. So basically, it's all the way opened up. It's two 90-degree angles against each other. All right, so this is where we're going to make the comparison to Unit 2. Remember in Unit 2, we did our segment addition, and there were two problems that we really focused on. We focused on two smaller segments adding up to equal the bigger segment that they are inside of. And then we focused on that segment, that midpoint problem. If a point was a midpoint of a segment, then the two sides were congruent. So just as with segments, we can break any angle into multiple smaller angles that can add together to equal the original angle. Angles that share a vertex are called adjacent angles. So, Unit 2, Unit 3. In Unit 2, we would say that this segment plus that segment equals that segment. So AB plus BC equals AC. In this unit, we would say that angle ACB plus angle BCD equals angle ACB. So let me slow down and write that out. Angle ACB, that's that top angle, plus angle BCD equals angle ACD. Basically what we're saying is if we start here and we travel this distance and then travel this distance, meaning opening up. Think about a hand on a clock, traveling. Okay, this amount of time and then this amount of time is going to be this whole amount of time. We have some special situations. So when adjacent angles add up to 90 degrees, we say that they are complementary. When they add up to 180, they are supplementary. You'll see supplementary more than you will see complementary. An angle bisector is a ray that is in between two other rays. So let me identify it right here. So this would be an angle bisector. And what happens is it splits that angle FCT into two equal angles. So an angle bisector is a ray, and that's what we just identified, that is in between two other rays, and that splits the angle in half. And when we say it splits it in half, we mean two congruent angles. So that would be similar to, in Unit 2, we said a midpoint. A midpoint splits a segment into two congruent segments. And remember for that, if C is a midpoint, that means that this side and this side are congruent. And we would put these little hash marks on there. So for an angle, we put these little arcs in there. So any angle that has an arc that matches another angle, they're congruent. Just like we can have double hash marks, we can have double arcs, just in case we need to separate them from some other angles that are congruent. So we could say that angle FCD is congruent to angle DCT. All right, some practice problems now. Notice how these problems will be presented to you. There'll be some given information, and try and identify where that information belongs in the diagram. So if they're saying ABC equals 40, notice ABC is the big angle. So that tells me that these two smaller angles, they should be adding up to equal that big angle. So 3x plus 2 plus 4x plus 3 that should equal the 40. Like terms, that's 7x plus 5 equals 40. Seven x equals 35. X equals 5. Now it didn't ask me what x equaled. It asked me what each of the angles equaled. So I'm going to take that 5 and I'm going to plug it back in. So this is 3 times 5, which is 15, plus 2, which is 17 degrees. And this is 4 times 5, which is 20, plus 3 is 23 degrees. 17 plus 23 is indeed 40. Notice that same idea from Unit 2. In Unit 2, we said, did they give us the entire length of the segment? Then we can add up the two smaller segments. Unit 3, did they give us the entire measurement of the big outside angle? Then we can add up the two smaller angles on the inside. Versus this idea that says that ray GP is a bisector. Which means that those two angles are congruent. So x plus 5. We can't add it to the other angle because we don't know what they should add up to equal. That was not given to us. Instead, it was given to us that they are equal to each other. I'm going to subtract the x from both sides. I'm going to add 10 to both sides. X equals 3. Take out x value and let's plug it back in. So this is 3 plus 5, which is 8. And this is 6 times 3, which is 18, minus 10, which is also 8. All right, so you need to ask yourself, do we know what the entire outside angle is? Or do we have the idea that an angle got split into two equal halves? Now this one just says find the two angles. So if we look at the diagram, we know that that symbol means 90 degrees. So we do indeed know that this outside angle is 90 degrees. So if I add up these two, we would say that they are complementary because they add up to 90. So 5x plus, I think it's a 13, plus 7x plus 17 equals 90. That's 12x plus 30. That's 12x equals 60. It's x equals 5. So we'll take that x value and we'll plug it back in. If x is 5, 7 times 5 is 35 plus 17 is 52. That's 25 plus 13 is 38. 38 and 52 is 90 degrees. Now there's several ways to do this problem. Some of them are a little bit easier than the other. What I want to just stress to you is that these two angles together make a straight line. We call that a linear pair. These two adjacent angles together basically have created a semicircle, 180 degrees. You'll need to be able to spot these quite a bit. They're going to show up many ways. They're not going to be, straight up and down like that. They might be upside down. They might be rotated. But we want to be able to look. This arc that I make means that I'm spanning from point A, basically going from 9 o'clock to 3 o'clock, 180 degrees. So that means that 95 plus 8x plus 5 should add up to 180 degrees. Now, you might not have done it that way. There might be an easier way for you to think of that. But that easier way, this is essentially what you're doing in your head. Actually, I'm going to take a step back. I kind of skipped the combined like terms there. 95 and 5 is 100. Subtract the 100. X equals 10. Find DBC. So DBC equals 8 times 10 plus 5, which is 85 degrees. A lot of work just for us to say, hey, if this is 95 and the whole thing adds up to 180, 180 minus 95 is 85. That's kind of the work that you'll be doing throughout the rest of the unit. This is the theory behind it. All right, take a look at the homework. I'm just going to talk about a couple things in the homework that I know if we were in class that you guys would have had questions about. 1 and 2, you're just naming the angle 4 ways. So look at the first page of the notes and look how we name the angle 4 ways. You can name it using the 3 letters in both directions, so that's 2 ways. You can name it using the letter, so the vertex, and you can name it using the number. On the rest of these, I'm going to stress to you a couple things. 1. When you see it written with this M out front, don't pay attention to that. That's really it's saying the measure of this angle. We're not going to write it that way, but you'll see that. If we had a book, that's how the book would write it, but just not something I'm going to be picky about. Identify where these measurements are in the diagram. Place them in there so you can visualize what is given to you. Did they give you one of the smaller angles? Or did they give you a bigger outside angle where the inside ones will add up to? Don't assume that the angles always have to add up to a nice number. And the algebraic expressions have to go on the inside. Okay, there's a problem, I think later on in here, when we start getting into these algebraic ones, where you're going to add up things that equal something that's algebraic. That's okay. Stick with the idea of what we're doing here and follow that process. All right, so that's the end of 3.5. Make sure you guys look at that homework. Email me with any questions, virtual office hours, and then complete the exit ticket so we can get ready for 3.6